In the last lesson, we talked about how you can write the equation of a line given the slope and the y-intercept. And it was simply a matter of plugging in the number that you have for the slope in for the m and the number that you have for the y-intercept in for the b, and then you would have the equation of the line. In this lesson, we're going to talk about what you can do to write the equation of a line given the slope and some point that is not the y-intercept. So before we dive into how we might do this, let's take a moment and really try to understand the situation, understand what we're trying to do and why this is a doable task. So I'm going to go put some coordinate grid on here. And let's say we are given some point. So in this situation, we're given the slope and we're given some point, not the y-intercept. So I am going to make up a point off the top of my head. We're going to make up this point. I don't even know what that point is. What is that point? 1, 2, 3, 4, 5, 6. That is the point 6, 2. Okay? So we just plunked one down there. And let's say I know the slope. Okay, well, backing up a little bit, there are an infinite number of lines that go through that point. I think we talked about this with the y-intercept. I could have a line with positive slope that is almost horizontal. I could have a line with positive slope that's very steep, and everything in between. We could have a line with negative slope. We could have it steep with a negative slope. We could have it not steep at all with a negative slope. Now, if I am given a specific slope, then I know there is only one line that goes through this point and also has a specific slope. So let's just pick a number for the slope. Let's just say the slope is 1/3. Okay, so if that's the case, if the line goes through this point and has a slope of 1/3, then from this point I can count up 1 and over 1, 2, 3, and locate some other point, and that would be enough for me to graph the line. And you can almost see how this is a doable thing. Now, I'm freehanding this problem here. Okay, I'm like just freehanding it on my iPad. But once you know a point and you know the slope, it's possible for you to go back and find the y-intercept. Now, from this freehanded graph, it appears that the y-intercept might be 0. Okay, but we know that like my line is wobbly here and I'm not using a straight edge. So maybe it's not, maybe my line bent a little bit. What I wanted you to get out of this illustration though is the idea that it is possible to find the equation of a line if you're given the slope and you're given some point, even if that point isn't the y-intercept. One of the ways that you can do it is to try to graph it. Okay, and so let's kind of explore that option, and then we'll look at a more sure algebraic way that will work for all the numbers and not just like the pretty numbers. So remember that the slope of this line is 1/3. And we would normally count up 1 and right 3, which is what I did here. I counted up 1 and right 3. But we could also count down 1 and left 3, because a negative divided by a negative would be a positive. And so in that case, I would be counting down 1 and left 1, 2, 3, which looks like it would put me right there. And then I could do it again, down 1 and left 3, and it turns out that I actually can find the y-intercept. The y-intercept in this case is the origin. It is the point 0, 0. And so my b value is 0. So if I were to write the equation of this line, I could write y equals 1/3 x plus 0. And we, of course, do not need to write the plus 0. And I have an unhappy feline. He thought he wanted to come to this math lesson, and now he's changed his mind. I don't know what his problem is. But I can just plug in the m and the b, and I can write the equation of a line. Now, not every problem comes out this nicely, okay, where you're counting and it's going to perfectly intersect at an integer. You might have numbers that are really big, like you might be up at 15,000 or something, and there's no way you want to count that long, even if it were possible. Like we don't have grid paper that big, and we don't want to count that long to get to the y-intercept. Or it's possible that you could be looking at some line that legitimately doesn't cross the y-axis at an integer, in which case you might have to estimate it. And we'd like to avoid doing that. So we're going to develop an algebraic way to come at this. Just remember that if you blank out on an algebraic method, you can always go back to the graphical method, because the graphs and the equations are just two ways of looking at the same thing. So let's take a look at, let's have an example here. Let's use a yellow pen. So we're going to write the equation of a line that passes through the point 6, -3, and has a slope of -2. All right, so here's the method. We know that the slope is -2, and we know that in this point, 6, -3, I have an x value and a y value. So I know that at least one solution to this problem, x is equal to 6 and y is equal to -3. And this is where it's important, like if we go back several lessons to what is the solution to an equation, it's the ordered pair, the pair of xy's or a pair of xy's that make the equation true. That's what frees you up to be able to try stuff like this and be confident that it's going to work. So what we have here is a possible x and the y value that goes with it. So looking at my formula, y equals mx plus b, this is how I teach this in my classes. I say we're going to borrow the x and we're going to borrow the y. Because I know the m value, I need the b value. I don't have the y-intercept, but I can find it. And the way I'm going to find it is I'm going to borrow y is equal to -3. I know because it was given to me in the problem that my slope was -2. I'm going to borrow x is equal to 6. And that means the only thing in this equation that I don't know is the b value. So let's go ahead and solve for b. -2 times 6 is -12. And then I'll add 12 to both sides. And just notice how the skills build. How not that long ago, at least not that long ago for me, I was doing a lesson on how to use the number line to add integers. And then those skills just roll over into the next thing. It's why math can be so difficult to make up once you start to fall behind. On the left-hand side here, we have -3 plus 12 is 9. And then -12 plus 12, of course, is 0. And now I know my b value. Now, don't lose sight of the directions. The directions are to write an equation. So that means if I don't have an equation as my answer, then I haven't done what the problem was actually asking me to do. Now, I mentioned borrowing, and I always ask my students, what does it mean to borrow something? Well, it means you take something, you probably use it, okay, and then you give it back. If you don't give it back, then you're stealing it. So we borrowed the x and the y value. We borrowed the 6 and the -3, but we don't want to keep them. We're going to give them back so that we have y. We're going to keep that slope because that's one of the numbers we need. And now instead of a b, we have a 9. And so we get the equation y equals -2x plus 9. I'm going to take care of this cat. Okay, I think we've made him happier. Now, just to confirm this, and just to, again, keep tying the equation process in with the graph process, let's go ahead and graph this situation to get a look at it and see if we can confirm this with the graph. So the point in this case was 6, -3. So 1, 2, 3, 4, 5, 6, 1, 2, 3. So right here. So I know the line goes through this point, and the slope was -2. So normally we would count down to and write 1, but that's going to actually take me in not the direction I wanted to go. So instead of doing -2 over 1, where we go down 2, I'm going to do 2 over -1. So I'm going to count up 2 and left 1. So up to left 1, up to left 1, up to left 1. All right. And that should do it. So we'll go ahead and maybe we'll connect the dots. There we go. And then let's just confirm where that y-intercept is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so the graph confirms what our algebra work over there got us. So that's pretty much the skill. I'll do another example. You can go back to like the word problems. I know in the last lesson we did a couple word problems. We can take a look at a word problem this time as well. Let's go back to the white paper. So let's do one more like this. Let's do the point is, I don't know, 3, 2, and a slope of 1. Okay, so we have y equals mx plus b. We have a candidate for the x, and we have a candidate for the y. Okay, because we know that if we plug in y equals 2, x equals 3, and a slope of 1, that will make the equation true if we have the right intercept. So we can actually go and use that to find the intercept. So y is equal to 2, slope is equal to 1, x is equal to 3, 1 times 3 is 3. Subtract 3 from both sides, and we get -1 is equal to b. Now remember the directions. The directions are writing an equation of the line. So if you stop here, you haven't done what the problem is asking you to do. So we were only borrowing the 3 and the 2. We need to go give them back. We'll keep the slope of 1, and now we have a y-intercept of -1. You can either write -1 or plus -1. And then, of course, we don't need to have that 1 written there, so we could just write y equals x minus 1. It's not wrong to put the 1 there, okay, if that helps you remember what the slope is. Let's take a moment and take a look at a word problem application, since this lesson is running a little on the short side. All right, let's take a look at this one. We have some kind of fitness program going on here. After 8 weeks on a fitness program, Greg can jog 30 miles a week. Now, I run. I do a lot of running. That's what I do to kind of keep my blood pressure down and stuff. And 30 miles a week is actually quite a bit of mileage, especially after 8 weeks. So I'm going to go with Greg probably was jogging before he started this fitness program. His average mileage gain has been 2 miles per week. Find an equation that gives Greg's mileage m in terms of the number of weeks that he stays on the program. Now, really, the concept of an independent and dependent variable, I don't think I really started to look at that until I was beyond Algebra 1. I think usually in Algebra 1, the teacher would provide the information of like, this is what your x is, this is what your y is, this is what's dependent, and so forth. But just to kind of touch on that a little bit, the number of miles he runs depends on the number of weeks that he's been in the program. Okay, and usually if a problem is well phrased, you can figure out which is the dependent and the independent variable if you say it the right way. So for instance, when I say the number of miles he runs depends on the number of weeks that he's been in the program, that makes sense because the longer you're in a fitness program, you're going to develop more fitness, you're going to develop more strength, more stamina, and you're going to be able to run more miles. If I switch that around and I say the number of weeks he's in the program depends on how many miles he runs, that doesn't actually make any sense. Now, it's true the two are related, but not in that way. The number of weeks doesn't change depending on how many miles. So he doesn't go from being in the program 5 weeks back to 4 weeks if he doesn't run as many miles or something like that. So it makes sense, like in a practical sense, to say that the number of I cannot get these words straight. Number of miles he runs depends on the number of weeks. So just for future reference, you can kind of file this away. Y is the dependent variable and X is the independent. So when you're trying to figure out like which variable in an equation should be the X and which one should be the Y, That's how you want to figure that out. You just kind of go through what are the two things. Now, I will tell you just like a pro tip here, like 99% of the time, if time, like weeks, is one of your variables, it is going to be independent because we can't bend time. It's independent. It marches on. It does not slow down. It does not go backwards, no matter how much we might want it to. Yeah, we can't slow it down. We can't speed it up. Time is pretty independent. So very, very few examples in actual context that will have like time as a dependent variable. Okay, and so in this particular problem, our n value is our x's and our m value is the y's. All right, so just kind of keep that in mind when you're doing the problem out. So somehow I gave myself 2 red pens on my little palette there. I didn't mean to do that. So let's see if we can write an equation for this. After 8 weeks on a fitness program, so what that tells us is our n value is 8. He can jog 30 miles. And that gives us basically an XY pair. 8 is the X. Remember, the number of miles would correspond with your X, and the number of weeks corresponds to the X. Sorry, I think I just said that backwards. And then the number of miles corresponds to your Y value. And that's our ordered pair. Now, we're given another piece of information in here, 2 miles per week. And that gets into that practical sense of what slope is. Slope is rate of change. It's how many miles more he does over or per weeks that go by. And so in this case, our slope is 2. Now, notice I wrote out the word slope there, and if you think for a moment, you can probably figure out why I did it, because it kind of is an issue over here. Instead of writing m equals 2, I wrote slope out because they gave us m as a variable, and I didn't want the m variable to be confused with the symbol m for slope. So now we've got all the information that we need. So we have our equation, y equals mx plus b. We have 30 is our y value, our slope is 2, our x value is 8, and 2 times 8 is 16. Subtract 16 from both sides, and we get 14 is equal to b, and so we could do 2 things at this point. We could do y equals 2x plus 14, or we could go with the variables they gave us, so the m and the n. So we could say something like the number of miles he runs is 2 times the number of weeks plus 14. And just to interpret that further, the 14, yes, it's the y-intercept, but it's also Greg's weekly mileage before he started the fitness program. So Greg was already running about 14 miles per week before he enrolled in this fitness program. And so that confirms my suspicions as a runner that he already had a decent base before he started this program. All right, so that completes this lesson, including a word problem. I'll put some problems on the next slide for you to practice on, and then I'll work them out, and then we'll go over them together. All right, here are 6 practice problems to look at, and possibly the world's worst green line drawn down there at the bottom. So all of these are just write the equation of the line. And this isn't the word of right there. It bothers my students when I do it. There we go. Because it's like a cursive F, but the top gets cut off, so it looks like a really messed up Q or something. Sorry about that. So the first one is goes through the point -3, 6 with a slope of 2. Then we have goes through 4, -2 with a slope of -1. Next one goes to the point 0, 4 with the slope of 3. Then 2, 5 with the slope of 0. -3, 4 with the slope of 2/3, because we can't forget how to work with fractions. And then there's an equation or a graph there. Write me the equation of that line. And that is supposed to go through the point -2, 2, even though my line isn't doing it. So pause the video at this point, work them out, and then unpause to check your answers. Okay, so for this first one, we're plugging in the 6 and the -3. 2 times -3 is -6. Add 6 to both sides, so we get a y-intercept of 12. And so the equation would be y equals 2x plus 12. On the next one, doing the same process with the 4 and the -2. And the -1, adding 4 to both sides, -2 plus 4 is 2, and then we get y equals -1x plus 2. You could also write for that y equals -x plus 2. That would also be correct. And then, as always with these, pause to write down any corrections that you need to make or to let yourself digest the solution. If you did not get those answers, you need to find out why. Next one. Now, for the third one, this one, if you're observant and you don't just go into autopilot, you might notice that this is the y-intercept. So you don't need to go through the extra step of solving it. Remember, the y-intercept is where a line crosses the y-axis, so the x-coordinate is 0. So the moment you see the x-coordinate is 0, then you know that the 4 is your b value, and you can jump right to y equals 3x plus 4. Now, if you didn't notice that, then the work would look something like this, where you plug in the 4 and the 0. 3 times 0 is 0, giving you the b value is equal to 4. And there's nothing wrong with that. It's just doing a little bit of extra work. So if you didn't catch that, make a little note when you do the correction, just that, if I notice that this is the y-intercept. For number 4, we're dealing with a slope of 0, but the process is the same. So don't let the fact that the numbers are different, stop you from doing the problem. The slope is 0, so we end up with 0 times 2, and so the y-intercept is 5. Then when you go to plug it in, you get y equals 0x plus 5. Well, 0 times anything is 0, and we end up with the x part dropping out, and that brings us back to like the first lesson in Unit 4, which was graphing your equations for a horizontal and vertical line. So this would be a horizontal line through the point 0, 5. Next one is the one with the fraction, and then what I did was some scratch work over here. So my work for the problem is actually in the red, and then the green over there is just a little bit of scratch work for teaching purposes. So we plug in the -3 and the 4 and the 2/3, and we want to solve for b. So 2/3 times -3 is -2. And then we add 2 to both sides to get 4 is equal to 6, or 4 is equal to 6, b is equal to 6. And so our equation is y equals 2/3 x plus 6. Now, if this kind of tripped you up a little bit, like, ooh, I'm not sure I could have gotten the -2, that's why I included the scratch work over there. So 2/3 times -3. Remember, -3 is a rational number, so it can be written as a fraction. When you multiply fractions, you go straight across. So we end up with -6 over +3. A negative divided by a positive is a negative, and 6 divided by 3 is 2. So we get the -2. And that's where that comes from. And then the last one, I actually did this. I kind of went off on my own here. There's a lot of different ways you can do this. So if you got y equals -2x minus 2, then you probably did it totally fine, because there's a lot of ways you could do it. The way I ended up doing it was I took the y-intercept, which I knew was -2, and I plugged that in for b. So instead of solving for b, I was like, oh, I'll just go ahead and solve for m. So I pretty much did the same process. I did, the x is equal to -2 and the y is equal to 2. So I plugged y is equal to 2, x is equal to -2, and then I grabbed the y-intercept, which I knew was a -2. Then I ended up solving for m. So I added 2 to both sides. Now, m times -2 is more comfortably written as -2m. So I just switched the order there. Divided both sides by -2 and ended up with m is equal to -2, because 4 divided by -2 is -2. And then that gave me the m and the b value, y equals -2x minus 2. Other ways that you could have done that. You could have counted the slope off of the graph over here. So you could have gone down 4 and right 2. Okay, and so using rise over run, you could have gotten the slope that way. You could also have gotten the slope from using the slope formula. all of those ways are fine. All of them are algebraically sound. I admittedly did this a little bit of an unconventional way because it's late and I decided to just do it a weird way. But all of those ways work. What's important is that you picked a way that's algebraically sound and you understand how you arrived at that answer. So that concludes our lesson on writing equations of lines given the slope and a point, not the y-intercept.